Welcome to CtrlShiftTech by DTG. Today, we're diving deep into something pretty transformative in AI, I think.
Yeah, definitely feels that way.
It's OpenAI's practical guide to building AI agents. Now, you've told us you want to get a solid handle on complex tech, quickly without getting totally lost.
And this guide is, well, it's basically perfect for that, packed with insights.
Think of this as your shortcut, maybe your cheat sheet, to understanding what these AI agents are really about. What they are when they're genuinely useful, and crucially, the principles behind building them.
We're not just scratching the surface here.
No, definitely not. Our mission today is to pull out the most important nuggets from this guide so you can navigate this whole AI agent space more confidently. It's moving fast.
Really fast.
Okay, so let's kick things off. What exactly is an agent in this context? Because it's clearly a step beyond regular software, isn't it?
That's a great place to start. The guide makes a really clear distinction. Conventional software, even simple LLM integrations like, say, basic chatbots, they automate specific steps or maybe individual tasks.
Right.
But AI agents, they take a much broader view. They're designed to act, well, independently on your behalf to manage entire workflows start to finish.
And a workflow, just to be clear, the guide defines it as a sequence of steps to hit a user goal, like resolving a customer service ticket or booking a flight, that kind of thing.
Exactly. Simple concept, but powerful when an agent handles it.
So what makes an LLM integration a true AI agent? What are those core characteristics?
The guide highlights two, really. First, the agent leverages an LLM, a large language model, for managing that workflow and, crucially, for decision-making along the way.
Okay, so it's thinking for itself, in a way.
It includes recognizing when the goal is met.
Yeah.
And even trying to, course correct if it hits a snag, handling failures proactively.
And if it can't fix it?
Then it knows when to stop, or maybe transfer control back to a human. That's key.
That is a pretty significant leap. It's not just following a rigid script. So what's the second characteristic?
The second is that the agent has access to and can dynamically select tools. These are essentially external functions, maybe APIs.
Right.
These tools let it interact with external systems, either to get more context or to actually take actions. And it does this all within defined guardrails.
So it's like giving the LLM hands and feet to operate out there in the digital world.
That's a perfect analogy, yeah. Reasoning, deciding, and acting with a degree of autonomy.
Okay, so that defines what they are. But here's a really critical question. When should you actually consider building one? It sounds powerful, but maybe it's overkill a lot of the time.
You've hit on a really crucial point there. The guide is very clear. Agents are best suited for workflows where traditional, rule-based automation just struggles.
Where it hits a wall.
Exactly. Processes that are maybe too complex, too many nuances, too many exceptions for a rigid system to handle effectively.
The guide uses that payment fraud analysis example. Can you maybe unpack that a bit more? Why is an agent better there?
Sure. So a traditional fraud system, it might just use a checklist, right? If transaction amount X or location is Y, flag it.
Standard rules engine.
Right. But an AI agent, it can act more like a human investigator. You can look at way more data points, understand the context of the transaction, spot subtle patterns that might indicate fraud, even if no single rule is triggered.
So it's about nuanced reasoning versus just ticking boxes.
Precisely.
That makes a lot of sense. So what are the clear signals then? When should you think, maybe an agent is the right tool here?
The guide points to three key indicators.
Yeah.
First is complex decision-making.
Okay.
If the workflow needs nuanced judgment, or it has to handle lots of exceptions, or make context-sensitive calls, think about approving a really complicated insurance claim, maybe. An agent's reasoning power is a huge asset there.
Got it. Complex decisions. What's number two?
Second is difficult to maintain rules. If you've got systems just bogged down by these massive, tangled sets of rules.
The kind that are always breaking or need constant updates.
Exactly. Error-prone, costly to update. The guide mentions vendor security reviews as an example. That can become incredibly rule-heavy and just a nightmare to manage. An agent that can learn and adapt might be way more sustainable.
Like trying to constantly patch an old legal document. Okay. And the third indicator.
The third is a heavy reliance on unstructured data.
Meaning things like text, conversations.
Yeah, if the workflow involves understanding natural language emails,
Yeah.
support tickets, whatever, or extracting meaning from diverse documents, or having actual back-and-forth conversations with users,
Yeah.
an agent's ability to process that kind of messy, unstructured data is a huge advantage.
Like understanding open-ended survey feedback automatically.
Perfect example.
Yeah.
A traditional system would really struggle with that.
Okay, so complex decisions, messy rules, unstructured data. If you see those, start thinking agent. But there's a but, isn't there? The guide adds a note of caution.
Absolutely, it's critical. Before you just drive headfirst into building an agent, you really need to validate if these criteria genuinely apply to your specific case.
Don't just build it because it's cool.
Right. Sometimes, honestly, a simpler deterministic solution, just a well-designed traditional program, might be perfectly fine, maybe even better. No need for a sophisticated agent if a simple script does the job well.
Good advice. Okay, so we know when an agent might be a fit. Let's break down what goes into building one. The fundamental components.
The guide keeps it pretty clear. 3 core building blocks. The model, which is the LLM, the brain. The tools, which are the agent's connection to the outside world. And the instructions, which guide its behavior.
Model, tools, instructions, brain, hands, rulebook. And OpenAI offers their agents SDK as one way to implement this, though you could build it yourself. Let's dig into each one. Models first. What are the trade-offs there?
Yet choosing a model is definitely a balancing act. You've got to think about, well, how complex are the tasks? How fast does it need to be, the latency? And, of course, the cost. More powerful usually means slower and more expensive, right?
Generally, yeah. It's that classic trade-off. Capability versus efficiency.
The guide mentions something interesting, using different models for different parts of a workflow. How does that work?
Exactly. Not every single step needs the absolute top-tier, most expensive model. You might use a smaller, faster, cheaper model for, say, simple stuff like pulling basic info or just figuring out the user's intent.
Okay.
But then you save the more capable, maybe slower model for the really complex reasoning parts, like that tricky refund decision we talked about. It's about being strategic with your resources.
Like shifting gears in a car. Makes sense.
Yeah.
So how do you figure out the right model mix? What's the process?
The guide suggests a pretty practical, iterative approach. Start by building your prototype using the most capable model you can for everything.
Go big first.
Yeah, establish that performance baseline, see what's possible, right? Then, once you have that, you start experimenting. Swap in smaller, cheaper models for different steps.
And see if it still works well enough. Exactly. See if they can still hit your accuracy targets for that specific step. This way, you optimize for cost and speed without accidentally sacrificing critical performance. It's not just about saving bucks, it's finding the minimum viable model for each job.
That's a really smart way to do it. Benchmark high, then optimize down. Okay, let's move to tools. This is where the agent actually interacts and does things.
That's right. Tools extend the agent beyond just thinking and talking. They're the bridges to external apps, systems, usually through APIs.
Right.
But what's fascinating is the guide also mentions that even for older, legacy systems without APIs, agents could potentially use these computer-used models to interact directly with the user interface, like mimic how a human uses the software.
Wow, okay. And AI driving old software, that really shows the potential reach here. So what makes a good tool in this agent context?
The guide emphasizes standardization, clear documentation, and reusability.
Yep.
Each tool needs a well-defined purpose, a clear interface, makes it easier for agents to discover and use them.
And easier for humans to maintain them, I bet.
Absolutely. Avoids building the same thing over and over. Think of it like a well-organized toolbox. You know what each tool does and how to use it.
Okay. And the guide splits tools into 3 main types.
Yep. First category is data tools. These let the agent get the information it needs. Querying databases, CRMs, reading documents, maybe even web searches for current info.
Makes sense. Got to get the facts. What's the second type?
Second is action tools. These let the agent actually do things. Update records, send emails or texts, maybe hand off a support ticket to a human if it gets stuck.
Data to understand, action to resolve. Got it. And the third type?
The third is orchestration. This is interesting. The guide points out that agents themselves can be tools for other agents.
Whoa, okay. Agents calling agents?
Yeah, we'll get more into that with multi-agent systems, but imagine having a specialized research agent that your main agent can just call like any other tool, like sub-teams delegating tasks.
That's a bit of a mind bender, but I can see the power. So the guide gives this example, conceptually, of equipping an agent with web search and saving results. But as you add more and more tools, doesn't that get complicated fast?
It absolutely can. And the guide suggests as the number of tools grows, especially if they start to overlap or get confusing,
Mm.
it's often a good idea to think about splitting the task across multiple, more specialized agents.
Keep each agent focused.
Exactly. Easier to manage, easier to make effective.
All right, model, tools. The third piece is instructions. How do you effectively tell the agent what to do? It can't just be a one-liner, right?
You're exactly right. High-quality instructions are absolutely critical. They reduce ambiguity, ensure the agent behaves predictably, makes sound decisions. It's the foundation for a reliable workflow.
So what are the best practices for writing good instructions?
The guide gives several good ones. One is to leverage existing documentation. Don't start from scratch if you don't have to.
Use what you already have. SOPs, support scripts.
Exactly. Standard operating procedures, policy docs. Translate that human knowledge into something the LLM agent can follow. Build on what's established.
Smart. Why reinvent the wheel? What else?
Another key practice, prompt the agent to break down complex tasks. Encourage it to think in smaller, clearer steps.
Like a recipe.
Precisely. It reduces ambiguity, helps it follow instructions accurately, especially with complex processes described in long documents. Step by step is better than just the ingredients list.
Make sense. Break it down. What else?
You also need to define clear actions for each step. Be specific, not just get customer info, but ask user for order number or call API X to get account details.
Even down to the exact wording for user messages.
Yes, being explicit really minimizes misinterpretation. And then crucially, you need to capture edge cases.
Ah, the real world. Things go wrong.
Right. Robust instructions anticipate variations. They include guidance on handling them, maybe conditional steps. If X, do Y, otherwise do Z, or alternative actions if info is missing.
Trying to foresee problems and give the agent a plan B.
Exactly. It's about proactive planning for those bumps in the road.
The guide even mentions using advanced models to generate instructions from documents automatically. That sounds like a massive time saver.
It really can be. They give an example prompt where you basically tell a powerful LLM to act like an expert instruction writer for another agent. Feed it a help doc, ask it to turn that into clear, numbered, unambiguous steps tailored for an agent.
Very cool. Okay. Model, tools, instructions. We have the pieces. How do we actually make them work together effectively to complete a workflow? That's orchestration, right?
Exactly. Orchestration is the mechanism, the conductor, that ensures the agent executes the workflow properly. The guide wisely suggests starting simple, an incremental approach.
Don't try to boil the ocean on day one.
Precisely. Start focused, then expand. And there are two main categories of orchestration patterns they outline.
Which are?
Single agent systems and multi-agent systems.
Okay, let's start with single agent. That feels like the natural place to begin for most people.
It usually is. A single well-equipped agent with good tools and clear instructions can handle a lot. You can incrementally add more tools to it without immediately jumping into multi-agent complexity.
Keeps things more manageable initially. Development, testing, maintenance.
Right. They talk about the concept of a run.
A run? What's that?
A run is basically one execution cycle, from the initial trigger or user input all the way until some exit condition is met.
Like what?
Could be the agent makes a final tool call that produces the result, or the model generates a direct response, or an error stops it, or it hits a max number of steps to prevent loops. It's one attempt to fulfill the request.
A self-contained attempt. Okay. The guide uses the simple what's the capital of the USA example for a run. So how do you manage complexity as a single agent gets more tools and more complex instructions?
One really effective strategy is using prompt templates.
Ah, reusable prompts.
Exactly. Instead of writing tons of different prompts for similar tasks, you create a base prompt with variables. So base prompt for retrieving info and variables specify what info.
So you only update the template, not dozens of prompts.
Right. Simplifies maintenance hugely.
Yeah.
And promotes consistency in how the agent behaves across related tasks.
Very practical. Okay, reusable templates help keep single agents manageable. But when do you need to make the leap to a multi-agent system? What are the triggers?
The guide suggests moving to multiple agents when a single agent starts hitting its limits. One trigger is really complex logic. Tons of if-then-else conditions making the prompt unwieldy.
Just too much branching logic for one prompt.
Yeah, it gets hard to manage and debug. Another key trigger is tool overload.
Too many tools for one agent.
Even if the tools are well-defined, if you just have so many or lots of similar or overlapping tools, even after trying to clarify them, it might be time to specialize. distribute responsibilities across multiple agents. It's about managing the agent's, well, cognitive load.
Keeping things efficient. Okay, so complexity in logic or tools pushes you towards multi-agent. Let's explore those patterns then. What does the guide highlight?
It focuses mainly on two broad applicable patterns, the manager pattern and the decentralized pattern.
Let's take the manager pattern first. What's the idea there?
In the manager pattern, you have a central manager agent. It's the coordinator. It gets a high-level task, and then it uses its tools, which in this case include calling other specialized worker agents to handle specific subtasks.
So the manager delegates.
Exactly. It delegates, then gathers the results from the specialists, synthesizes them, and provides a unified response. The key is that central control and context stays with the manager.
The guide uses that translation example, hello, into multiple languages. How would that work with a manager?
Right, so the manager agent gets the request, translate hello into Spanish, French, and Italian. It recognizes it needs language specialists.
Okay.
So it uses its tools to call a Spanish translation agent, a French agent, an Italian agent. Each specialist does its translation, sends the result back to the manager.
And the manager collects them all.
Collects them, maybe formats them nicely, and gives the user the complete answer, like a project lead compiling team reports.
Got it. The guide briefly mentions declarative versus non-declarative frameworks for this. What's the difference?
Declarative often means defining every step visually, like a flowchart. Can be clear, but rigid. Non-declarative, like the code-first approach in the agent's SDK, uses programming logic, offers more flexibility, adaptability, especially for complex dynamic flows.
More like writing code than drawing boxes.
Yeah.
Okay, now the other pattern, decentralized. How's that different?
In the decentralized pattern, agents act more like peers, no central coordinator. Instead, agents can directly hand off tasks or entire conversations to other agents based on specialization.
A direct transfer.
Usually a one-way transfer for that part of the workflow.
The example is customer service triage. How does that play out decentrally?
Okay, imagine a customer contact support. A triage agent gets the query first. It analyzes it. This is about order delivery. It knows the specialized order management agent handles that. So the triage agent performs a handoff, transfers the conversation, the context, everything directly to the order agent.
And the order agent takes over with the customer.
Exactly. Like passing the baton in a relay race to the next specialist.
Seems useful when you don't need that central oversight and specialists can just run with their part. Can the receiving agent hand it back?
Yeah, the guide mentions that possibility. Adds flexibility if the first agent needs to re-engage later, maybe after the specialist gathered more info.
Okay, fascinating patterns. Now, we've built and orchestrated these agents, but we need them to be safe, responsible. That brings us to guardrails. Why are they so crucial?
Absolutely fundamental. Guardrails manage risks. Data privacy breaches, generating harmful content, reputational damage. You need protection. The guide strongly pushes a layered defense.
Not just one fence, but multiple layers.
Yeah, exactly. Use multiple specialized guardrails. Makes the system more robust, more resilient, like having different types of security systems protecting a building.
The guide shows this concept of combining different types. What layers do they suggest?
They illustrate combining LLM-based guardrails, using the model's own understanding to spot bad stuff, with traditional rules-based ones like rejects or block lists.
The simpler checks.
Right. And also things like the OpenAI moderation API for flagging harmful content specifically. Each layer acts as a filter, checking user input and the agent's planned actions or outputs.
Checking both sides. Makes sense. So what are the specific types of guardrails they detail?
Okay, there's a relevance classifier, keeps the agent on topic, stops it from answering questions outside its scope.
Prevents rambling.
Pretty much. Then a safety classifier, detects harmful inputs, jailbreaks, prompt injections, that sort of thing.
Protecting the agent itself.
Yes. A PII filter is vital, prevents exposing personal info. Moderation tools like the API, flag harmful output, hate speech, etc.
All essential. What else?
Tool safeguards. This is about assessing the risk of each tool. Is it read-only or write? Are actions reversible? What's the potential financial impact?
Rating the tools by potential damage.
Basically, yeah, low, medium, high risk. High-risk actions might trigger extra checks, maybe even demand human review before execution. Like you'd want tighter checks on a tool that makes payments versus one that just reads public data.
Makes perfect sense. More caution for bigger actions.
Then there are simple rules-based protections, keyword block lists, length limits, rejects patterns, and finally output validation, ensuring the agent's responses align with your brand voice and don't say anything damaging.
A really comprehensive safety net. How should people actually build and implement these? Where do you start?
The guide recommends focusing first on data privacy and content safety. Get those basics covered. Then, as you see real-world issues, edge cases, failures.
Learn from mistakes.
Exactly. Iteratively add more guardrails to address those specific vulnerabilities you discover. But it's a balance. You need to optimize for security and user experience. Guardrails shouldn't make the agent unusable.
Right, finding that sweet spot. How does the agent's SDK handle them? Something about optimistic execution.
Yeah, optimistic execution basically means the agent proceeds with its task while the guardrails check things in the background. If a guardrail catches a problem like PII about to be leaked, it throws an exception, interrupts the process before the bad thing happens.
So it's checking in parallel, trying not to slow things down unless necessary.
That's the idea. A safety net that catches things in real time without adding huge delays.
Okay, so we have agents, orchestration, guardrails, but the guide still emphasizes human intervention. Even with all this tech, why are humans still needed?
It's a critical final safeguard, really, and also a crucial feedback loop for improvement, especially early on. Humans spot unexpected failures, find new edge cases no one thought of.
Things the automated systems miss.
Right. Human review provides invaluable feedback to refine instructions, tune guardrails, build better evaluations. It's about having that human in the loop to ensure quality and learn quickly.
What kind of situations typically trigger needing a human?
Two main triggers highlighted. First, exceeding failure thresholds. If the agent keeps trying and failing, misunderstanding the user, tool errors piling up, it should escalate to a human.
Don't let it spin its wheels forever.
Right. The second trigger is high-risk actions. Things with significant consequences, big cancellations, large refunds, major payments. Those should probably involve human oversight, at least until you're very confident in the agent's reliability for those specific tasks. What's really striking is how these agents are moving beyond just doing tasks to actually reasoning, adapting, interacting. It's a big shift.
It really is a significant step in AI's evolution. And hey, for you listening, if you want to keep up with shifts like this in tech, we cover web dev, testing, DevOps, all sorts of educational content. Make sure you subscribe to the DTG channel. That's DTG Dev Test Go. Lots of deep dives like this one.
Definitely worth checking out.
So wrapping up our deep dive into OpenAI's guide on AI agents, hopefully you've got a much clearer picture now of what they can do and what goes into building them.
Yeah, from the core bits, models, tools, instructions through orchestration patterns, and hitting those crucial guardrails and the need for human oversight.
Yeah.
It's a solid framework they've laid out.
I think the main takeaway for me is that building these things is iterative. You start simple, you test your ideas, you constantly refine based on how it actually performs.
Absolutely. And thinking about the potential automating entire end-to-end processes, not just single clicks, it could really change how workflows operate across so many fields.
So question for you listening, what aspects of AI agents grab your interest the most? What real-world problems do you see them tackling effectively? It's worth thinking about maybe digging into the guide yourself. This field is moving incredibly fast.
And that raises bigger questions too, right? How do we integrate these more autonomous systems responsibly, ethically? That's a conversation that's only just beginning, I think.
Definitely. Well, thank you for joining us on CtrlShiftTech by DTG for this exploration. We really hope it sparks some aha moments.
Hope it was useful.
And one last reminder, do subscribe to the DTG channel for more tech discussions than this. Until our next deep dive, keep exploring.